Prepare to rethink everything you thought you knew. This is Mind Benders, your source for the most mind-twisting facts that will expand your understanding of the world. Let's bend some minds.
Opening scene. Haunting, ambient music begins. The screen is black. Narrator. Voice is calm, deep, and resonant. From the moment we first looked up, we have asked questions. We are a species defined not by the answers we have, but by the mysteries we chase. We have mapped our world, decoded our genes, and split the atom, pushing back the darkness of ignorance with the flickering candle of science. Yet, for all our progress, we stand before two colossal peaks, their summits lost in the clouds of the unknown. These are not just scientific puzzles, they are the two fundamental questions that frame our entire existence. As the great physicist Michio Kaku and others have noted, these are the ultimate mysteries. The first is the mystery of the out there, the universe. Music shifts, becoming more orchestral and awe-inspiring. Narrator. Where did all of this come from? We call the beginning the Big Bang, but that's just a label for a moment our physics cannot yet penetrate. We look out into the void and see wonders that defy imagination. We've learned that the stars, the planets, the galaxies, everything we can see, everything we've ever known, amounts to less than 5% of the total universe. The other 95% is a combination of dark matter and dark energy, invisible substances whose gravitational effects orchestrate the grand cosmic ballet, yet whose true nature remains a profound enigma. We are strangers in our own cosmos, surrounded by an invisible reality. But the second great mystery is not millions of light years away. It is closer than our own breath. It is the mystery of the in-here, consciousness. Music shifts again, becoming more intimate, curious, and slightly eerie. Narrator. Somehow, inside this skull, a 3-pound lump of gelatinous tissue, an electrochemical machine of staggering complexity, produces you. It takes in raw data, photons hitting a retina, air vibrations striking an eardrum, and transforms it into the subjective experience of seeing the color red, hearing a symphony, or feeling the warmth of love. How does this happen? How does inert matter, the same carbon and water that makes up the stars and the dust between them, wake up and become aware of itself? There is no equation for joy, no scientific unit for sorrow. This is the so-called hard problem, the seemingly unbridgeable gap between the physical processes of the brain and the private, internal universe of the mind. These two questions, one of cosmic origin, the other of inner awareness, are two sides of the same coin of existence. To understand the universe is to understand the stage on which we play. To understand consciousness is to understand the actor. In this series, we will journey to the very edge of human knowledge. We will walk with the astrophysicists decoding the echoes of the Big Bang, and the neuroscientists mapping the labyrinth of the mind. We will explore the cosmos without and the cosmos within. The search for these answers is the greatest adventure we have ever undertaken, and it has only just begun. Opening of Part 2. Music swells from the intimate theme of Part 1 into a grand cosmic score. The image of the eye reflecting the stars remains for a moment. Narrator. Let us begin our journey outwards, into the first great mystery. We pull back from the human eye, the small vessel of perception, and let it be swallowed by the immensity it is trying to comprehend, the cosmos. Our origin story is written here in the language of light and gravity, a story that begins 13.8 billion years ago in an instant of unimaginable creation. We call it the Big Bang, but the name is a misnomer, a cosmic understatement. It was not an explosion in space, like a firecracker in a dark room. It was the explosion of space itself. Everything, all matter, all energy, every dimension we know, including time, erupted from a single point of infinite heat and density, a singularity so alien to our experience that our laws of physics simply break down when we try to describe it. In that first searing moment, the entire universe we now see, with its 2 trillion galaxies, was smaller than a single atom. How can we possibly know this? We can't visit the beginning of time, but we can see its echo. If we build a powerful enough radio telescope and point it at any empty patch of sky, we detect a faint, persistent glow, a whisper of microwaves, leftover heat from the crucible of creation. This is the cosmic microwave background, the oldest light in the universe. It is the universe's baby picture, taken when it was just 380,000 years old, a snapshot of the moment light was finally free to travel through space. This picture, however, presents a puzzle. The temperature of this ancient light is almost perfectly uniform in every direction we look. It's as if 2 opposite ends of the universe, which have never had time to be in contact with each other, somehow agreed to be the exact same temperature. To solve this and other conundrums, physicists proposed a radical idea: cosmic inflation. The theory suggests that in the first fraction of a second after the Big Bang, the universe underwent a period of hyper-expansion, growing faster than the speed of light, smoothing out any initial wrinkles into the flat, uniform cosmos we see today. It's an elegant theory that matches our observations with stunning precision. But it comes with a mind-bending consequence. If inflation happened once, what's to stop it from happening again and again? The mathematics of inflation suggests that our Big Bang may not have been a singular event, but just one bubble forming in a vast bubbling foam of cosmic creation. Our entire universe, with all its galaxies and wonders, may be just one island in an infinite cosmic ocean, a multiverse. Suddenly, the question, where did the universe come from, becomes even bigger. We have pushed back the darkness, only to reveal an even greater, more profound unknown. If we are just one universe among countless others, do they have different laws of physics? Is there life in them? And what is the mechanism that generates them all? The edge of our universe is not the end of the mystery. It may be the beginning of infinity. Opening of Part 3. Music is deep, mysterious, and grand. We are floating through the conceptual multiverse from the end of Part 2, a sea of cosmic bubbles. Narrator. The possibility of an infinite multiverse is perhaps the most humbling concept humanity has ever conceived. But even if we set aside that staggering idea and return our gaze to the familiar shores of our own cosmos, the mystery only deepens. Because the story of our universe is not written by the stars we see, but by the darkness between them. The great cosmic drama is being directed by actors who refuse to take the stage. In the 1970s, astronomer Vera Rubin was studying the rotation of galaxies like this one. She expected to see what we see in our solar system. Objects farther from the center move more slowly. Mercury orbits the Sun far faster than distant Neptune. But that's not what she found. The stars on the outer fringes of galaxies were moving just as fast as the stars near the center, defying the known laws of gravity. It was as if some enormous, unseen mass was gripping the entire galaxy, holding it together and preventing its stars from flying off into the void. This phantom mass, which doesn't shine or reflect light, was given a fittingly enigmatic name: dark matter. Scientists now believe this invisible substance outweighs all the visible matter in the universe, all the stars, planets, and gas clouds, by a factor of 5 to 1. It is the invisible scaffolding upon the universe is built, the gravitational anchor that sculpted the cosmic web and allows galaxies to exist at all. We know it's there, we can measure its gravitational pull, but we have no idea what it is. But dark matter is only part of the puzzle. It accounts for about 27% of the universe. The familiar matter we're made of is less than 5%. So, what is the remaining 68%? The answer came from another profound discovery. For decades, astronomers assumed the expansion of the universe, started by the Big Bang, must be slowing down due to the mutual gravitational pull of all the galaxies. But in the late 1990s, by observing distant, exploding stars, they found the exact opposite. The expansion is accelerating. Something is actively pushing the universe apart, acting like a form of anti-gravity. This mysterious, repulsive force has been named dark energy. It appears to be a property of space-time, a constant, pervasive energy woven into the fabric of the void. It is the winner in a colossal cosmic tug-of-war. While dark matter's gravity tries to pull the universe together into magnificent structures, dark energy relentlessly pushes everything apart on the largest scales, determining the ultimate fate of our cosmos. So, here we are. 95% of our reality is composed of two substances we cannot see, cannot detect, and cannot explain. We are adrift in a cosmic ocean, unaware of the currents that guide us or the true nature of the water. We have peeled back a layer of the cosmic onion, only to find a far greater mystery underneath. Narrator. The search for answers continues. To join us on every step of this journey into the unknown, make sure you subscribe to Mindbenders and turn on notifications. You won't want to miss what comes next. Opening of Part 4. The music is a blend of the grand cosmic theme and a more pensive, questioning melody. We are looking at the vast cosmic web from the end of Part 3, with galaxies connected by filaments of dark matter. Narrator. We have journeyed to the edge of space and time, peering back into the dawn of creation and out into the vast, dark unknown that constitutes our reality. We are surrounded by mysteries, a universe that exploded from nothing, a cosmic expansion that defies gravity, and an invisible architecture of dark matter holding it all together. But every observation, every calculation, every theory about this grand external cosmos must pass through the lens of a single extraordinary instrument, and that instrument is the source of our second and perhaps even greater mystery. All of our cosmic knowledge has been gathered, filtered, and understood right here, behind our eyes, inside our skull. Having explored the cosmos without, we must now turn our journey inward. We must pivot from the unfathomable scale of the universe to the equally unfathomable complexity of the 3-pound universe that perceives it. We turn now to the mystery of consciousness. Music shifts, becoming more intimate, intricate, and laced with a sense of wonder. The sound of a soft, rhythmic heartbeat is subtly mixed in. On the surface, the problem seems simple. Our brain is a biological computer, the most complex object we have yet discovered. It contains nearly 100 billion neurons, each one connected to thousands of others, forming a web with more possible connections than there are atoms in the known universe. These neurons communicate through tiny bursts of electricity and chemical signals. It is a machine, a wet, biological, electrochemical machine. This machine is a master of processing data. When you look at an apple, photons with a wavelength of roughly 650 nanometers strike your retina. Specialized cells convert that light into an electrical signal. That signal travels down your optic nerve to your visual cortex at the back of your brain, where it is processed, categorized, and identified based on past experience. We can map this entire physical pathway. We can measure the electrical impulses and track the flow of neurotransmitters. But here, science hits a wall, a chasm, because out of that purely physical, objective process of firing neurons, something utterly magical and mysterious emerges: the subjective, private, internal experience of seeing the color red. There is nothing in the physics of photons or the chemistry of synapses that explains the feeling of redness. This is what philosopher David Chalmers called the hard problem of consciousness. How and why does inert, unfeeling matter give rise to the rich inner world of subjective awareness? How does a collection of cells produce the soaring joy of listening to a symphony, the sharp sting of regret, or the simple, profound awareness that you exist? This is not a question on the frontier of science. It is the question that defines the frontier. It is the dividing line between the known and the truly unknown. The search for the universe was a search for our home. The search for consciousness is a search for ourselves. Music shifts, becoming more intimate, intricate, and laced with a sense of wonder. The sound of a soft, rhythmic heartbeat is subtly mixed in. On the surface, the problem seems simple. Our brain is a biological computer, the most complex object we have yet discovered. It contains nearly 100 billion neurons, each one connected to thousands of others, forming a web with more possible connections than there are atoms in the known universe. These neurons communicate through tiny bursts of electricity and chemical signals. It is a machine, a wet, biological, electrochemical machine. This machine is a master of processing data. When you look at an apple, photons with a wavelength of roughly 650 nanometers strike your retina. Specialized cells convert that light into an electrical signal. That signal travels down your optic nerve to your visual cortex at the back of your brain, where it is processed, categorized, and identified based on past experience. We can map this entire physical pathway. We can measure the electrical impulses and track the flow of neurotransmitters. But here, science hits a wall, a chasm, because out of that purely physical, objective process of firing neurons, something utterly magical and mysterious emerges: the subjective, private, internal experience of seeing the color red. There is nothing in the physics of photons or the chemistry of synapses that explains the feeling of redness. This is what philosopher David Chalmers called the hard problem of consciousness. How and why does inert, unfeeling matter give rise to the rich inner world of subjective awareness? How does a collection of cells produce the soaring joy of listening to a symphony, the sharp sting of regret, or the simple, profound awareness that you exist? This is not a question on the frontier of science. It is the question that defines the frontier. It is the dividing line between the known and the truly unknown. The search for the universe was a search for our home. The search for consciousness is a search for ourselves. This chasm between brain and mind, between the objective firing of a neuron and the subjective feeling of an emotion, has forced scientists and philosophers to abandon old maps and chart new territory. How do you build a bridge to an island you can only ever visit alone? If we cannot directly observe the subjective experience of another, how can we possibly explain its origin? The search for an answer has led us down several fascinating and radically different paths. One of the most prominent ideas is that consciousness is not a fundamental thing, but an emergent property. Think of temperature. A single atom doesn't have a temperature, but an aggregation of atoms does. In the same way, a single neuron isn't conscious. It's a simple biological switch. But connect 100 billion of them in a network of unimaginable complexity, and perhaps awareness simply materializes. A phase transition occurs, like water freezing into ice, where a new collective property arises that was absent in the individual components. Consciousness, in this view, is the symphony that emerges from an orchestra of mindless cells. But this idea, while intuitive, is difficult to prove. Where is the tipping point? A newer, more radical theory attempts to measure consciousness. It's called Integrated Information Theory, or IIT. Proposed by neuroscientist Giulio Tononi, it suggests consciousness is not about computation, but about how integrated a system's information is. A system is conscious if its web of cause and effect is so deeply interconnected that the whole is irreducibly greater than the sum of its parts. Your experience of seeing a red apple is a single unified whole. You cannot break it down into separate experiences of redness, roundness, and shininess without destroying the experience itself. Under IIT, consciousness is a fundamental property of reality that can be measured with a value called phi. A high phi value signifies a high degree of consciousness. This leads to a startling conclusion. Consciousness is not exclusive to brains. Anything with a high enough degree of integrated information, perhaps a sufficiently complex AI, or even the biosphere of a planet, could possess its own form of awareness. But other thinkers, like physicist Roger Penrose and anesthesiologist Stuart Hameroff, believe the answer lies deeper still. They argue that the classical physics of neurons is insufficient. To bridge the gap to the mind, we must descend into the strange, probabilistic world of quantum mechanics. They propose that consciousness arises from quantum computations orchestrated within the microscopic protein scaffolds of our neurons called microtubules. This idea, while controversial, is tantalizing. It suggests that the mystery of the mind is intrinsically linked to the deepest mysteries of matter and energy, the very same quantum rules that governed the Big Bang. It hints that the two great mysteries, the cosmos without and the cosmos within, are not separate questions at all. They may be reflections of each other, rooted in the same fundamental and deeply strange reality. The patterns of the universe may echo in the patterns of the mind. This search for answers is the defining feature of our species. We are the universe's curiosity made manifest, and we are building new eyes and new minds to see further and think deeper than ever. We are designing telescopes that will one day capture the light from the very first stars, and perhaps even analyze the atmospheres of distant Earth-like worlds for the chemical fingerprints of life. Simultaneously, we are creating artificial intelligences and brain mapping technologies of breathtaking sophistication, hoping to decode the neural language of thought and subjective experience. We are sharpening our tools for the final ascent on these two great peaks of ignorance. But what if the answers we find are stranger than we can currently imagine? What if, as some physicists now speculate, information is the true fundamental reality and both matter and space-time are just expressions of it? What if the brain does not create consciousness, but acts more like an intricate receiver tuning in to a field of awareness that permeates the universe? These are not questions for science fiction, but active lines of inquiry at the absolute bleeding edge of theoretical physics and philosophy. The mystery of existence is so profound, no idea, however strange, cannot be dismissed out of hand. In the end, this grand quest for the universe without and the universe within is not about finding a final neat solution. It is about the journey.
The world is full of fascinating paradoxes, isn't it? We hope today's facts truly bent your mind. If you're ready for more daily revelations that challenge the norm, subscribe to Mindbenders. Don't forget to ring the bell so you never miss a new video. Until next time, keep questioning.